So first of all, Murphy. Ava, come here. There's Ava. They're good dogs. Okay. So we are working in section 5.5 and we are dealing with roots. And roots that are zeros can come in either real forms or complex forms. And so a couple of things. Complex, they always come in pairs. So if a plus bi is a root, then so is a minus bi. They always come in pairs. Okay? Now, if you are dealing with real roots, you either have rational roots like 3 or 4 or 2/3 or 7/10, or irrational roots. Now, for us to find the irrational roots, we really need calculus in order to be able to do that. For rational roots, we have this system that we can use, and we have a function where it's some number. We'll call it q, and there's a reason why in a bit. It's just notation, but for now it's qx to the n, and then we have bx to the n minus 1 plus dot 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 plus cx to the first plus p. So the p is the constant, and the q is the first coefficient. And what happens is any possible rational root will come from factors of p, factors of q, or the ratio of p over q. Okay? So factors of p, factors of q, or factors of p, I'm saying that poorly. When I do the example, you'll see that you'll take the factors from p and put them over the factors of q. That's the better way to say it. Okay? Now, we're going to go to an example. So our example is the polynomial 2x to the 4th minus 10x to the 3rd plus 11x squared minus 15x plus 12. All right. So first of all, our p is 12. That's the constant at the end. Our q is 2. Okay? And we know that we have 4 roots that we're looking for. Okay? Now the factors of p, and you always do this, you put plus or minus in front, because if a positive number is a factor, so is a negative number. Okay? So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. That is the list of possible factors for 12. For 2, it's plus or minus 1 or plus or minus 2. Now, for all of the p over q's, so what you're trying to do is potentially generate anything that's new. So if you're taking your p and you're putting it over 1, you're not getting anything new. If you put 1 over 2, so you take your p over your q, you've got plus or minus a half. Okay, so you're taking these and putting them over these. So we have plus or minus a half. That's a new one. If I put 2 over 2, that's nothing new, it's just 1. 3 over 2, we get our plus or minus 3 over 2. 4 over 2, well that's just 2, and 6 over 2, that's just 3. So these are the new ones that are generated from dealing with the p over the q. Okay. Now there's this goofy thing called Descartes' rule, and it helps us to be able to determine how many positive roots there are and how many negative roots there are. And so what you do is you look at the function and you look at the sign changes and how many there are. So if we go from positive to negative, that is one sign change. Negative to positive, that's a second sign change. Positive to negative, that's a third sign change. Negative to positive, that's a fourth sign change. And the way this works is you will either have 4 positives, or you'll have 2 positives, or you'll have no positives. So this 4 here is this 4, and then it always goes down by 2, then 4, and so forth. It always counts down by an even integer. Okay. Then you also do the odds to see if there are negatives. And I'm saying odds, that's the wrong term. Negative x to be able to determine if there are negative roots. And what you do is you take negative x and you put it in place of the x. And so you have 2 in parentheses negative x to the 4th, and you have negative 10, negative x to the 3rd, negative 11, negative x to the 2nd, negative 15, negative x to the 1st, plus 12. Well, negative to the 4th is just positive. Negative to the 3rd is a negative, so a negative times a negative is a positive. Negative squared is a positive, and a negative comes out to the negative, making it a positive. So all of these are pluses. There are 0 sign changes. And what that means is there are 0 negative roots. So in all of our possibilities up here, we get to now ignore the negatives. Now, this is the possible type of combinations you can have. You can have 4 positive, then you'd have 0 negative. We know we're going to have 0 negative because of what we just discovered. And you could have 0 complex. You could have 2 positive and 2 complex, 0 positive and 4 complex. All right, so I'm using synthetic division, and these are just trials that I did, okay? I tried 2, I tried 3, I tried 3 halves, and I got to 4. And again, you just write down each of the coefficients with their sign, bring the 2 down. So 4 times 2 gives me my 8. Negative 10 plus 8 is negative 2. 4 times negative 2 is negative 8. These two add to 3. Then 4 times 3 is 12. I get negative 3. 4 times negative 3 is 12. We get a 0. That means this number is a root. Okay. And now this part is really what we can refer to as a reduced equation. If I were to write it out as a polynomial, it would be 2x to the 3rd minus 2x squared plus 3x minus 3. So let me slide over here real quick. We know that 4 is a root. That means x minus 4 is a factor. Okay. Now we travel back over here, and we're going to try 1. I just gave 1 a shot. I tried 2, I tried 3, I tried 3 halves just to see the process through, and I'm at 1. So I'm going to bring down the 2. 1 times 2 is 2. Negative 2 plus 2 is 0. 1 times 0 is 0. Here's my 3. 1 times 3 is 3. There's my 0. So this is now my new reduced equation. And again, since 1 is a root, x minus 1 is a factor. Okay, so I'm going to take my reduced equation, and so this is really 2x squared. That's 0x, and that's 3. And it looks like this. So I have 2x squared plus 0x plus 3. Now, really, we have this set equal to 0 because we're trying to find the roots. And you could factor it. Actually, you can't factor it, I'm sorry. And that's denoted here because I want the 2 times the 3. That gets me a positive 6. And factor pairs of 6 without a negative in there won't add up to 0. So I did the quadratic. This is my b, this is my a, this is my c. So I did negative b plus or minus b squared minus 4 times a times c all over 2 times a. So I got 0 plus or minus the square root of negative 24 over 4. Okay, so here we make this a positive and we pull the I out. So now we have plus or minus I, the square root of 24 over 4. Okay, square root of 24 breaks up into the square root of 4 and the square root of 6. Square root of 4 is 2. And if you'll notice, I have this 2 over 4. And before we deal with that, we generally write it 2i, square roots of 6 over 4. These two will reduce, and so we're left with plus or minus I times the square root of 6 over 2. Now you didn't have to do the quadratic. You could have just recognized that you're just setting 2x squared plus 3 equal to 0. Move your 3 to the other side, and then divide by 2. You're going to take the square root on both sides. And if I impose the square root, I need to put in the plus or minus, okay? And you'll notice this negative here, and anytime there's a negative underneath the radical, we make it a positive and we pull the I out. And we're going to split this square root over the division bar, so it's the square root of 3 over the square root of 2. And we don't like square roots in the denominator. You can ask at another time if you'd like, I'd be happy to answer. But we're going to rationalize square root of 2, square root of 2. Well, these two in the denominator multiply to 2, and the square root of 2 times the square root of 3 is the square root of 6. So we have positive I squared roots of 6 over 2, and we have negative I squared roots of 6 over 2. And these are our complex roots. Okay, hopefully that's helpful.